let's move forward to inheritance concept. I will take time for inheritance concept and interface concept because it's very important for us. So let's create a package for it. Like, suppose I'm creating a class. Okay, let me show you something. It's my personal note. See, suppose there is a parent class which is car. Okay, and there are some common things, common properties of every car. In your BMW, in Honda, in Audi, there are some common properties. Every car can start, every car can stop, every car can refuel. So these are the common things. Every car can execute some common tasks, right? So let's suppose create a car class, then BMW, Honda, Audi, this all the things are coming after creating a car. Before that, it hasn't come. So let's create a parent class for it first, car class, the main method, or let's suppose we don't need main method. Okay. So this is my car class. For now, I don't know it is parent or child. I don't care. So okay, let's close these extra things from here. Bothers me sometimes. Okay, so this one system of a car, first system of a car, every car can start. So let's make a method for it, non-static method, public void start, fine. And okay, so I've done a mistake here. This start method, public void start, this is, let's print out something. Okay, so this is the start, okay, start method from car class. Fine till now. Then let's suppose every car can stop. So it's common, public void stop now. So let's print it out. Stop method from car class. Suppose these two features are common for every cars. And now let's create another class. I'm not making it child, I'm not making it anything, just a simple Java class, and I'm naming it as BMW. Yes, smaller letter, you know. BMW. Here we are not creating main method again. Suppose now here BMW has some specific features. Suppose it's my class body. Okay, fine. So public void. Suppose the spatial feature is BMW car. Suppose it has boosting. So public void boost option. So boost method from BMW car. BMW class should be. Suppose this is the single method, single system for BMW class till now. Okay, so suppose you are not watching this thing. You have no, I mean, you have no access in these two class, car class and BMW class. In your company, they are saying you that okay, test the classes and all. So suppose you are creating a method that is called test car. You have access in that method only, and you're creating it with public thing. So because you want to test here. So see guys, now if I want to create an object for BMW class, what I have to do? BMW object or OB, whatever I want to say, new BMW constructor. So as I have created this object. So guys, let's clear it up to you. As I told before, that whenever we are giving a data type, it is creating a box. Here it is still doing the same thing, no difference. It is creating a BMW type box. Then the box type is now class type, and we know that in class type box we can only store objects. We can only store objects. Suppose this is object. And what is the object here? Object value we create object in that way. Whenever we are writing this code, the object is created in that way, and we do it with the help of a constructor. So don't think this BMW constructor is storing here something like that, blah blah blah. No, it is making something like an object, and this object can access in everywhere in your class. It is superpower like octopus. He can go anywhere you want. Okay, so let's suppose BMW object. Now, in with this object or with this variable, in which method we can access? Generally, in general sense, we can only access as we have created the object for BMW class, which is this class. It has only one method, boost method. So in general sense, in normal sense, we don't know inheritance, we know nothing, but in normal sense we know that if we create an object of a class, of a particular class, with the help of that class constructor, we can enter the method of this BMW class, all the methods and variables of this BMW class. So let's suppose object is here. Now if I give dot, see, boost method is showing. So the method I've created in car class, I mean start method and stop method. Is it watching here? Can you see it here in the list? Is it present? No, it is not present. So basically, it is. I'm trying to understand these things as well, guys. It is very important. Here it is written. There is a colon. After colon is written void here. That means it is telling us that okay, that boost method is not returning anything. So this is very important. That's why I'm just telling you. So now, what this BMW is meaning, guys? Can anybody tell me? Anyone? If not, fine. Okay, this BMW means where is it coming from? In fact, every method, see hash code. Here it is written int. It is indicating you that this method is going to return you an integer value, a int value. If it returns int value, you definitely have to store it in the int box. And from where it is coming from? It is coming from object class, either object class or either object interface. It can be anything, but for now it is showing that. Okay, so now the boost method is coming from BMW class, and we know that all the methods, all the things will come from the class where we have created our object. This object is created inside BMW class. So all the methods of BMW class should come. So only boost method is coming. No method is coming from car class. So okay, let's suppose let's click on this one. So it is a method from BMW class. Now if I to write object dot, same thing, Nothing is changing. Now think, guys. Now see, if I make him the children of car, I mean, if I do that this rule, if I do this relationship like BMW car relationship, so I want to make BMW as a child of this car class. So what will I do? I have to use extends keyword, extends car. See, now you cannot see anything here, right? Same method is here. Only one method is here. But guys, trust me, the back end, like this method has come. Like this two method has arrived here directly. You and I, you and I cannot see it. So, but it has come. Let me. Uh, I will make you understand a little bit. Let me do this thing for you guys. These two methods have come in the backend. I haven't gone into overridden concept. Don't worry about it. Just trying to make you understand what is extends for. So extends is it is not overridden yet. The methods are not overridden, but the method has added here in backend. You cannot see it right now. So here in the test car class, now if see as I'm saying that okay these things are in backend. Why do you need to believe me? So tell me, you can tell me, okay, prove it that this method has arrived. Then I have to prove you guys, right? So, okay, so I know that when I called with this object, I know that only the BMW's methods will arrive, right? So now, as I'm saying that the method has already added here, all the methods of car class has added here in the backend. So then it must have to become in the list now. So let's see. Okay. So start it's here, which is coming from car class. Stop void, which is coming from car class. BMW. Now how this thing is showing here? It should not be seen here. Right? Am I right, guys? So how it is happening? It is happening only for inheritance. BMW is now inheriting all the properties, though you cannot see it, but with the help of this object, you can use these methods as well. Now, if I want to see, if I want to run it, or suppose start method from this class, so boost method from BMW class, but start method from car class. Directly, we can use the object of BMW class for calling the car class methods. This is called inheritance, inheriting properties. It is inheriting properties. Now we can do the same thing for stop method as well. It is also it is also not returning anything, but it is coming from car class. This is very important, guys. So guys, can you anybody tell me now the list has arrived? Who is reading it, JVM or compiler? Who is reading it now? Anyone? Okay, so let me tell you. After pressing here, JVM will read it. But now JVM is not going to read it. After execution, JVM is going to read it. The result we are getting, this is compile time. Compiler is reading it. Everything you are watching is with the help of compiler, not JVM. That's why I have understood. I have made you understood this concept at first. This is so important. So compiler is thinking that okay, it is coming from car class. That's fine. So let's write stop and let's run it up. Okay. Now these two things are coming from car class, and first one is from BMW class. Same thing we can do it from different packages as well. Now another question arises. Whenever I've created child class object, parent class can access into it. But if I create, I mean, parent class methods we can access with the help of that object. But if we create parent class object, can we access the child class object, child class properties? I mean, child class methods. So see, guys, if we create object for this one, if we create object for this one, this BMW class, it will inherit from its parents. But if you create object for this one, it can inherit properties from its parents, but no parent can inherit properties from child, right? It is in our real life as well. A parent cannot inherit any properties, but child can inherit properties because child is having birth of that parent. So okay, so same thing if we want to write now with a child class object, method from BMW and method from class, method from car, we can access both BMW methods and car class methods. But if I make it car class object right now, sorry, it's new. So it is directly giving me error in this method because these are coming from car class. It is we can access those things, but this is coming from child class. So it is not possible that we can access a car class. I mean, in this class, even if you build this, you have built this relationship. This class cannot inherit properties from its child. It cannot in the backend as well. There is no method in that way. So that is the main inheritance concept. Overriding is different part. So now see here now we will go to the overridden concept. So this is just inheriting system, how things are inherits properties, something like that. So what is overriding concept? It's again a very important thing. So let's suppose now I know it is in backend, but I want to change something. I don't want to print like from car class. I don't want to print it. I want to change some code. So I don't have to inherit it only. I have to change the code as well. But as I told you, in this car class, you cannot access. Suppose this is the class made by your company and he is not giving you access in this class. But when you are creating object or when in this class, you know that well, if you extend it, these methods, start method and stop method is coming from the car class. That means there is a chance you can override it. Okay, so now in BMW class, suppose you have access, you want to change something in this thing, like it is there, it's fine. I mean, in car class, it's fine. But do you want to change something in this start method? Just you have done same thing here. You have copy paste, not copy paste. You have created a start method. That's all. Now you cannot, as it is overridden, you cannot do anything. It is overridden. How do I understand? How am I sure that it is overridden? First thing, there is a green arrow in Eclipse. You will see that this is gonna indicate you that this is overridden. This arrow is going to indicate that this method is overridden. Fine. So then what is happening? Then suppose you want to change something like, oh sorry, so you want to change that start method from BMW class. Okay, from BMW, not from car. Okay, now in the test card, let's again undo this thing. Let's make it BMW car class object with this child object. Now if I call this thing, okay, let me call you from the first thing first. Okay, so if I want to call start, now see it is coming from, sorry, not this one, start. It is coming from BMW class here. It is written. So understanding this name is so important if you want to write, if you want to read static and dynamic polymorphism. So try to understand this concept. So when we have created object of BMW class, when we have created uh, with the class reference, and when we have created object with BMW class constructor, it is taking the same overridden method start, but it is taking from BMW class. Now it is not taking from parent class. So if I want to run it, so see, now it is taking start method from BMW class. That means now it is not printing from parent class. So if I ask you now, guys, who is reading it? I mean, who is reading this thing? The start method is showing BMW. Is it written now? It is written JVM or compiler? Definitely, it is compiler, right? As I told before execution. Suppose now I have forget that I have executed it, but the list is coming now. It is before execution. So who is reading it? Compiler is reading it. The compiler is understanding that okay, this thing is coming from BMW. So what compiler is saying that? Compiler is saying that okay, compiler is saying that compiler is assuming that this is coming from BMW class. Fine. So let's execute and see that actually it is coming from BMW class or not. So where is it? Okay, start. See guys, it is coming from BMW class. So now compiler is deciding right. That's why we call this system when we create an object of a class and you try to call an overridden method. This method is overridden. We call it static polymorphism or compile time polymorphism actually. You can say that. Okay, let me write it here. Calling overridden method here with the help of child class object plus object reference. So child class object reference and child class constructor. So when you are making child class object reference and child class constructor, and with that object reference, it is compiler is deciding, compiler is watching that the method is overridden method is coming from child class. So compiler is writing that way. That's why we call it. That's why we call it compile time polymorphism or static polymorphism. Compile time polymorphism or static polymorphism. Good to know, right? So then, now suppose you know that okay, it is coming from child class. It is not coming from parent class, and it is decided by your um, compiler right now. Now suppose we can do one thing. Let's suppose in test car class, let's make it like the object reference I want to okay, see, in car class, car is the parent. He should have the power to name his child, but child shouldn't have the power to name his parent or something like that, or create anything for parent. But parent has a right in our real life as well. Parents have a right to do something in our life. So let's make the thing in that way that car class object, I am referring it with the help of parent class, but I'm making child class object. So I am taking help for, I'm making the box which is car type. When I'm writing car, it is making a box which data type is non-primitive, and this is a class type. Which class? Car type box. But inside that box, what we are storing? We are storing the value of the child. I mean the object of the child. So suppose we are storing the value object of the child is BMW. Now what will happen, guys? We are doing it, but what will happen? So see, at first, let me tell you. Suppose comment it up. Now suppose what we can do. Please don't forget, guys. Static polymorphism. Why we were telling that cause compiler was right at that time. So now see what is happening. If I want to add object here, so see what method we can see here. Object dot. We can see start method. We can see a stop method only. Only these two methods. Though we have created child class object, we cannot access to child class method. So what we have done here is a very famous interview question, guys. The thing is called top casting. The thing is called top casting. We have done top casting. With the parent class object reference, we are creating the object of child class. So okay. So when we are doing top casting, what method is coming? Start and stop. So guys, I need your response right now. Can you tell me, Celia, that from where this start method is coming from? Celia, are you there?
Yes.
Can you please tell me?
From the car method, from the car class, I believe.
Yeah. But can you see a boost method here? I mean, no method is coming from child class. You are sure about it, right? When you are doing
Yes,
top
right. Yeah,
casting.
it's not coming from. Yeah.
But now, who is reading this? JVM or compiler? The
It's a
start method is
compiler.
coming from car class. Perfect. Now let's run it. So we are sure that it is coming from car class. It is coming from stop class. Now let's run it. Oh, sorry, I haven't called it. Start method is from car class. Okay, just think about it. It is coming from car class. Let's run it right now. But it is giving result from BMW class. Why? So you cannot call the BMW class method directly with top casting system. Compiler is wrong in this time. Compiler cannot judge it. So actually it is overridden in BMW class. This start method is coming from the overridden method is coming from child class, but other method is okay, fine. If you want to call like the stop method, object dot stop. Now see, if I run it, it is exactly coming from car class. But when there is a common method, overridden method with the child, with this child, with BMW constructor child, if there is any overridden method, after running, compiler cannot judge it. After running, after execution, JVM is pulling the method. JVM is going to the child class constructor. He is pulling the method from child class. That's why compiler cannot decide it. It is deciding after running the code, after running the execution. That's why when we do top casting, when we call a overridden method from a parent class, though compiler is reading that, we are calling it from parent class, compiler is showing us that it is called from parent class, but it is called from exactly after running the code, it is calling from child class. So we call it runtime polymorphism. This time JVM is right. I mean JVM is doing the work. Compiler is not right now. Here compiler was right. That's why we called it compile time polymorphism when we do create a normal object of the child class. But when we are doing top casting, it is decided by Java. That's why we call it runtime polymorphism or dynamic polymorphism. That's nice till now. So these are two polymorphism concept. So now guys, one thing has come in mind that okay, so why we have seen that we have written overwritten queue or something like that. Okay, yeah, that is good. Now if I want, I can change anything of this method. I can change. I can make it different. Start one. I can do anything like whatever I want. The overridden concept has gone. But what is the power of override method is? I mean override word is like override annotation is. This override annotation gives a restriction. You cannot change anything except the body here. So if you want to change the return type, you cannot. If you want to change the name, start one now. You cannot. It will give you error. So when you have written override annotation, you must have to overwrite the thing. Yeah, exactly what it is, but you can change here. Like you can write just BMW plus. It is not going to give you error. Why we do that? Actually, in real life, you will see inside overridden method, inside like the inside the method from parent class, there will be so many input parameters and all, which should be used in exactly that way. Suppose there is written int salary, there is an int expense, and there is written int profit. You have to every time you are calling it, you have to put it in that way, like or have I written that? Okay. Suppose this is in a stop method. So okay, if I want to override it, so if I want to override it here, stop. So that formation, that thing is created by our company. We cannot access in this thing. So if we want to work here, so I know they will tell me that what I have to put inside. I have to put the salary here. So at first, suppose it is $20,000, and I have to put my expense. Suppose $5,000. Then I have to put my another thing is my profit, $15,000. Actually, in that way, we have to call. We have to. I mean, sorry, I have done wrong here. I just called it. I'll just put the thing exactly in that way how it has written there. Okay. Okay. Stop. Okay. I have to exactly do the same thing here so that I cannot change the formation given by company. Okay. So I have to follow this thing. I have to follow this procedure. If I want to call it in main method, I have to put values in that way. If I want to change it, I cannot change it right now. If I want to put salary here, expense here, so it is not possible. Why? Because the formation is created by our company, and every employee of your company is going to input the things in that way. Whenever they are going to call it, they are going to call this method from as it is public. So they have to put salary at first, expense at then, and then profit. But if everyone is mixing up, that someone is writing salary here, expense here, someone is writing salary here in this position, there can be so many like miscalculation or something like that. I'm just giving you a scenario, so it can vary according to companies, but overwritten concept is created for that reason only. I mean, override annotation is created for that reason only. Okay guys, so now next thing is, as we have covered, static polymorphism. Overriding is something like that. So overloading, inside method overloading, we have understood that creating the same name method multiple times is called method overloading. And what is method overriding? Method overriding is when we are creating a child class, when we're making a relation, if the child class method and parent class methods are having the same name, that time we are calling it overridden method. When the method is having the same name and body is changed, you have changed something inside the body. I mean, you have created a newly generated method. But if it is inherited by itself, it is not overridden. Now, stop method is here. but it is not overwritten. It has come by inheriting only. So that is the thing. If child class method and if child class and parent class having the same methods with the same name and same input arguments, that time we can call it overridden method. Even now, if I remove the keyword at override, still it is overridden method. Still it is having the same name, same input parameters, and there is a green logo for that showing that it is overridden. So this is our overridden concept. Okay, in method overloading, there is another famous interview question: can you overload main method? So yes, let me see. Public void main. This is our main method name. So no, here is one input argument. We are not going to give any input argument here. So if we can do that, yeah, we can overload main method as well. If it is an interview question, just answer in that way. So yeah, now our here, are we missing something like any topic? We have covered dynamic polymorphism, static polymorphism, then we have covered inheritance. Yeah, good till now. Okay, another last thing is there. If I tell you, can a class, can BMW can be child of different classes? I mean, different parent class. Suppose it's coming from car class right now. BMW is here. Suppose. And there is another thing is called, suppose another class is there, vehicle. Can BMW directly extend to class, to parent? It cannot. So let's make it. Let's just make a class. Let me show you this thing. Vehicle. Okay, I didn't need main method. Public void. Suppose it has got an engine method here. Can BMW class extends multiple things like car, comma, vehicle? It is not allowed in Java. Even if you write in capital letter, okay, it is not allowed in Java. I mean, you cannot extend multiple class. So see, guys, this thing is called like, okay, let me show you. This is the last concept of this inheritance. Okay, here. This thing is called diamond problem, guys. So any one interview question come in that way that if a child class can inherit can extend from multiple parents, no, like there is a BMW is there is a bike, there is a car, there is a boat, parent 1, parent 2, parent 3, he cannot inherit any of them. So it creates a shape in that way he cannot inherit from multiple parents at a time together directly. He can inherit multiple parents, but not directly. He cannot extend directly to different parents as well. He have to come in a sequence. So this thing is called diamond problem. So for omitting that, we have our interface concept. Another thing, let me teach you. So okay, what is that? Just hold on. Cancel. Okay. Now let me tell you something. There is a grandparent relationship in inheritance as well. I've missed that concept for going deep inside. Let me show you the diagram at first. Okay. Suppose we know that for now I have understood that car class is there. BMW is a child of car. But suppose there is a parent of car is vehicle. So here, car can inherit properties from vehicle directly, and BMW can also inherit those properties. Whenever if you have that relation, he can inherit all the properties from all the class, like physics, engineer, but they have to be parent of each other. Like vehicle have to be parent of car class, this class. Automobile have to be parent of vehicle class, something like that. If they are all the grandparents, suppose vehicle is a grandparent of BMW class. BMW can inherit properties from vehicle class. Automobile is the grandparent of car class. So car can inherit properties from automobile. Even BMW can also inherit all the properties from automobile as well. Let's see it in real example. Suppose let's, as we have limited time, let's talk about, let's think up to vehicle right now. Just this relation we will see that it can inherit properties from vehicle or not. Okay, so as we have created vehicle class and here is the engine method, let's make car class a child of vehicle class. So let's make it extends vehicle. So if car class extends vehicle, then car has become the child of vehicle class. It is having all the methods of vehicle class. We already seen that in BMW car class relation. But now my concept is BMW extending car class, not vehicle class. BMW is extending car class only. So car is the parent of BMW and vehicle is the grandparent of BMW. Let's see now he can access with the help of BMW object. Let's make it BMW again. With the help of BMW object, can you start the engine method or not? So at the back end, we are assuming it is inheriting means, okay, let's write something here. Okay, this is my car class. Sorry for that. Sorry, engine vehicle class. Okay, method. Let's print it engine method from vehicle class. Fine. So how it is coming here? We are thinking that we are assuming that we are copying it and we are suppose testing it while BMW. We are assuming it that with this method it has arrived here in backend, right? We cannot see it, not as a overridden method. Just normally it has inherited the properties. So now with the object of this class, we should access this method, okay, from car class. So let's see. Is our test class, okay, with the help of object ob dot. See now engine method is here. Can you see, guys? And it is coming from vehicle class. It's void type. It is coming from vehicle class. So guys, this is the way, like it is inheriting from multiple grandparents as well, but you cannot directly extend with class to class. I mean, you cannot use extends keyword for multiple class at a time. So that is a diamond problem for us. So if I run it now, so we can see that engine methods from vehicle class is coming. So this is the wrap up for our uh, uh, inheritance concept. Like what we have to understand: static polymorphism, dynamic polymorphism, top casting is very important. Now, guys, I will not. I'm assuming that you understand a little bit of things regarding inheritance concept, interface concept. Now I will teach you in the thing why we write in Selenium driver equal to new Chrome driver. What is happening there? I will understand that concept with the help of interface concept. So this is very important. So many of us doesn't know that what is happening at that position. So we have to do that. Before that, okay, let me give you a shortcut of object shifting. There is a thing like we shift object. Suppose this BMW object. So this is a car object, suppose, and this is a BMW object. Guys, if we want to shift the object, this object into the car class, there is a trick. We do this. We have done this thing in take screenshot method. So we don't know what we have done in our batch. So just let me teach you the thing that what we have actually did. So if we write here car, so okay, let me tell you, we have created the box of car class, and we have created the object of BMW class. It is a BMW class object. Sometimes it is necessary to shift the object, make the object for car class. We suppose you don't want to do static polymorphism, you just need the method from your car class, start method from your car class. So as you've seen that before, that BMW is having stop and car class having stop as well. So now you want this class. So guys, just see that if you want to shift it, so you can just write in that way. If we write in that way, now if I want to print object dot stop, it's coming from car class as before, like you have we have seen. So now if I want to print it, okay, sorry, I haven't given any command right here. Okay, BMW class. Okay. Now the object has shifted to car class, but it is printing the value of overridden method from BMW class, because constructor is still BMW right now. But this is the way we should. There are so many other purpose for object shifting. As we have taken a screenshot, we have shifted the full driver into the object class. So this is called this dynamic polymorphism. We already know that. So object shifting is important for like taking screenshots, creating so many things uh, regarding screenshot methods and other stuffs as well. So it is a different class for shifting object from one class to another.